We now know how to obtain derivatives from first principles. And what we're going to do now is to try to obtain or demonstrate rules of differentiation. We're going to try starting with general functions of the form x to the power of n. You probably already know that the rule to differentiate this kinds of functions is to drop the power and have x n minus 1, but maybe you've never seen the actual demonstration. So this is what we're going to try to do. The basic ingredient is actually to do a binomial expansion. Right? So you'll find them in the lecture notes. You'll talk more about it in Physics 113. Here we're just going to use it. If you have questions, you can come to me on Teams and I'll show you how to do it, but I've also included examples here in the lecture notes. Differentiating from first principles, remember, means calculating the limit when h goes to 0 of f x plus h minus f of x over h. In this case, f of x is obvious, and what we need to know is how to get f of x plus h. So this is where the binomial expansion really comes in, and we can actually write this if f of x is x to the power of n as x to the power of n plus n x n minus 1 times h plus 1.5 n minus 1 x n minus 2 x to the power of 2 all the way to the final term, which should be h to the power of n. So the crucial step to showing this is knowing how to perform binomial expansion. It means that you're going to be plugging in this enormous train into this expression, and then you're going to be subtracting x to the power of n. And you'll see that all the other terms will remain except this one. For convenience, and because I've already written the entire train, I will leave it here and try to simply sub in. So imagine that this term is that one, so I'm going to subtract x to the power of n at the very, very corner, and I'm going to divide it by h, and this is what we're trying to calculate, the limit when h goes to 0. The only obvious thing that you can do to begin with is to cut out the terms that actually just contain x. The good news is that every other term along the remaining train contains an h. This means you can cut it off here, you can cut this off, and you can lower down a power, including this one that becomes n minus 1. So it means that at this point you can actually take the limit. You're no longer dividing by something that's tending to 0. And we can have a look at the behavior. Now the important thing here is after cancelling h, all terms will still have an h, so they will be going to 0 except for this term. So it means this one goes to 0, all the other terms go to 0, this one goes to 0 when h goes to 0, and therefore the limit when h goes to 0 of this for the function is just this term, n x to the power of n minus 1. And it means we have demonstrating this differentiation rule. Again, the crucial thing here is really knowing how to binomial expand this expression.